Hi everyone, this is Thijs, technical evangelist at Varnish Software, and I'm back for episode 2 of my conversation with Matt Levine from CacheFly. He is the CTO and founder of CacheFly, and in episode 1 we already talked to him and talked about multi-CDN strategies in general and how CacheFly was built on top of Varnish Enterprise. Let's switch it up a bit. Matt, talk us through some of the challenges that you're facing when operating a CDN like yours at such a scale.
I remember I personally bought CDN. I won't say who I bought it from somebody in 1999 for $2,000 a megabit. And I have customers today trying to buy it 8 or 9 cents a megabit. So that's the scale of how cheap CDN has gotten. But to your point, the volume has obviously gone up, exponentially more than the price has dropped, which is great. That shows, people are doing more on the internet. There's more broadband penetration worldwide. Markets, the internet is going to continue to grow for the foreseeable future as, countries and continents are starting to build infrastructure and catch up and get the majority of the population online. So the pie is still growing. But having said that, I think the real challenge today, as opposed to 10 years ago when it was a CapEx game, I'll change my answer slightly. It was never a CapEx game. That's just what you were tricked into thinking. So that was just the barrier that made you say, okay, maybe I won't do this, or this is going to be too hard to deploy to XYZ. But once it was up, it turns out that was the easy part. And the hard part is delivering a consistent experience globally 24/7. So,
well, I have this simple expression. It's a little bit more of a joke we say internally that like running a CDN, it's like 20% caching and 80% networking. Does that apply at your end?
Like 298 is probably for us. Like the possibly because we have we've relied on Varnish to solve most of the caching for us. Operationally day to day, we don't talk too much about problems with the cache, but we do talk all day long about problems with the internet at large.
But people think that's probably a misconception that a CDN is just a collection of reverse caching proxies somewhere in different locations, and then you have this magic service that aggregates them and distributes loads based on geolocation and consumption of backend services. But it's a lot more complicated than that, obviously.
Well, I think it can be that simple. It really depends what your performance goals are. Like if your goal is to say, I built it and therefore it's good, then your first definition works great. But if you actually say, no, it needs to deliver, 3 megabit HLS streams at 6 p.m. on the East Coast at the same time that the Super Bowl is happening, well, now it's probably a different definition. So one of the challenges we get into as an industry in CDN, and I think it's going to change over the next few years, but the definition of speed today is pretty much what is your best case scenario. And so when you use what is the best case scenario, you can actually build a really awesome CDN. Just, if you just said, well, I'm just going to put up a whole bunch of reverse proxies, I'm going to do geo. But that's not what the 99th percentile is, or even the 50th percentile. That's the super low hanging fruit.
The images, the static images that are just easy. Like one client has a bunch of images, nothing really changes, no complex routing, no rule sets, just cache control, max age, 3600, we're good.
And not a ton of objects. Like most CDN testing today. So I don't want to jump ahead, but for multi-CDN, frequently people are doing performance testing. And, realistically, it's like, what is the performance of a 100 kilobyte test object in RAM in our servers in Equinix Los Angeles connected directly to Comcast, let's say, versus another CDN's 100 kilobyte test object that's in RAM in Equinix LA who's directly connected to Comcast network.
Let's talk about something like, let's have an origin server somewhere in Los Angeles, and let's talk or let it be consumed by people who sit in the Philippines. It's a different story, probably.
It's a very different story because your cache hit ratio, and then what specifically your cache byte ratio, matters a lot, because that test object that, let's say, we serve from Singapore or Hong Kong to a user in the Philippines is always going to be great unless some really bad thing is happening. And it's going to be great on every other CDN too. Nobody's really bad at delivering frequently accessed small objects that they know drive multi-CDN decisions. Everybody's good on the test object. But the test object is becoming less and less representational of the end user experience. So immediately you're saying, oh, this CDN is very fast from cache in RAM, and then you have it serve an object that's really big and not in RAM. Now there's specific industry-based solutions to solve for that, specifically video. Right? If you have video and you have a really good QoE solution, you will see that and feed that data back into your multi-CDN selection. You'll say, you know what, we did serve X number of objects via this CDN to the Philippines, and the performance didn't match up with the test object because the objects weren't in cache and they were really slow getting across the ocean. And we're going to feed that back into the multi-CDN selection and adjust some things. But that's where we are. Is the first the first metric is the test object, which you have to be having a really bad day if you're a CDN and you can't serve the test object fast. That's like a Windows update or Call of Duty or one of those days on the internet to be really bad at the test object.
Well, the Call of Duty, that's always a good one, right? Whenever there's I have to admit, I play Call of Duty every time they work with this concept of season. So you purchase the game, you play it, and then every now and then a new season of the game gets released, and that's like, I remember a 35 gigabyte package that you have to download.
There's an 80 gigabyte one a few weeks ago.
Like, I know a new one is coming up anytime soon, and I'm not excited. It's like, one night I just can't play, I just leave it download and install. But what people don't know is that this has a major impact on bandwidth on the internet. Like, millions of people are playing this, millions of people are downloading a minimum of 30 gigabyte package, and millions of people preferably do that at the same time, because if they don't, they can't play multiplayer.
Right.
So it's like a big deal for the internet.
That's
like a headline, right? Call of Duty is a big deal for the internet.
Correct. It doesn't make news in the traditional sense, but certainly within network engineering circles, everybody pays attention. Everybody knows what the schedule is. Everybody starts talking with each other when it actually comes out to see where the challenges are. But truthfully, we don't intentionally go for that business today, because that is at the bottom end of the pricing spectrum I mentioned earlier. They're definitely not paying $2,000 a megabit anymore to distribute Call of Duty patches. So we see our vantage point is a little different, because what we see is a ton of multi-CDN customers swing to us because we're the ones not serving Call of Duty in their multi-CDN mix. So we see it as a pretty big day for us, even though we don't actually we don't actually serve any of those updates. Yeah,
because there's still the other traffic on the internet, right? When it swings one way, while you swing the other way, because you have to sweep up all that traffic that on a day-to-day basis is being served on the internet.
Yeah, it's all those other customers whose performance started dropping off that then start to move it around. So it's always a busy day for us, but not for the same reason as the release. It's the second and third network effects, if you will, from what happens when the release comes out. So it's truthfully though, it's a fun day. We like, for better or for worse, we come to work every day to get to solve those problems. And thankfully, in as long as we've been doing it, we haven't seen too many days, weeks, months where we're like, oh, there's nothing to figure out today. The internet's just working and nobody's slow and there's no fiber cuts across the Pacific Ocean and everything's great. That hasn't happened yet. So once that day happens, we'll be pretty bored. But in the meantime, it's a challenging day from an engineering standpoint, but it also feels good to help customers and find those paths that are faster during those challenges. And that all just goes back to your point about 2080.
Yes, absolutely. Because that's even another thing that people have a hard time recognizing. It's not about the infra in the data center, because that's also an easy part. You just put capacity, you put dedicated servers or virtual servers there. you install caching software like Varnish Enterprise, but then it's a matter of finding the right like network path to your end user and doing that with a quality of experience that is good. And especially for very content that is very sensitive to latency. Like if I may believe the stats, about 80% of the internet is video these days. And video, people don't like buffering. Like that's like my kids are that way. As soon as they see the little wheel spinning, they're just tune out.
Yeah. Yeah, and that's where those fun parts happen. So the best example is, let's say, we're pretty substantially peered at Equinix in Singapore. Those are the first ports that get congested during a big event. So we end up almost immediately moving a lot of traffic off of peering, which seems counterintuitive, but finding the right transit to get back to a network that we otherwise would be sending over peering. We have a lot of playbooks for that reason, that's the saturated part. And if you want to get the video in and you don't want the spinning wheel, you need to be optimizing
detour,
your
right?
network.
So you're taking a little detour to get where you're supposed to be getting instead of via direct peering.
Because everybody else is blasting those peering ports in that moment. Yes. So the question, it's obvious what's being blasted. The question that we ask ourselves is, okay, so if that's full, what would be open? And sometimes that means shifting networks between POPs. So let's say that hypothetical network in the Philippines might have been coming in Hong Kong. Maybe during a burst event like that, we swing it to Singapore or maybe Tokyo. But all of that is happening for all the big networks, all on the internet, all at the same time. And that's the hard part about running a CDN is that. And, the people that do a great job of running CDNs that aren't commercial CDNs typically have a pretty big staff to do those things as well.
But we see it happening, like most of our clientele builds their own CDNs either exclusively on top of Varnish or otherwise in a hybrid setup. Like they have a multi-CDN where they have a local network, like a local CDN built entirely on top of Varnish. And then for the bursts and for global access, they just use one of the commercial CDN partners. Yeah. Because it seems counterintuitive. You have so many CDN as a service players out there, and yet people build their own CDN, but they have very good reasons for that. And like it's always the same two things. They want the flexibility and the control, and otherwise the price has to be right, because everyone could build his or her own stack. That's the easy part. It has to make financial sense.
And even if we're talking about, large gaming updates, the Seattle area customer who breaks the internet with updates for their gaming console that we're talking about also built their own CDN. But when it's a Call of Duty update, they don't have the scale and they don't want to go through those hoops of like, okay, we just filled a port with X. Now we need to go find additional capacity in Tokyo or somewhere else. So even, that's a company with a $1 trillion market cap, and they still go, oh, we don't want to have to operationally execute this at peak. Let's, send it to the commercial CDNs. So that's a model we see as well, is a lot of people like to keep things in-house until some threshold is hit, whether that's a performance threshold or it's a pricing threshold or it's a capacity threshold, and then they use the commercial CDNs for overflow.
And the other way around as well. They use a local CDN often to protect their origin from the impact of CDN revalidation, because CDN is just a cache, right? So when as soon as an object expires, the next request will trigger a revalidation request and potentially get an updated object. But if you have so many points of presence in your network and you operate at a global scale, all those connections might end up DDoSing your origin.
Sure.
So what people do is they build a little, shouldn't be a necessarily large CDN, but a local one using Varnish perhaps, or one of, there's plenty of other software out there as well, to just create an origin shield and to protect that origin from poorly behaving CDN nodes.
Yeah, and we see bigger customers too segment the type of traffic. So the biggest example would be Apple, right? So Apple's built their own global CDN to deliver software updates. And they have a tweaked TCP stack on it that's intentionally not that performant, so as to it's basically the BitTorrent protocol, but the idea is it will go as fast as it can without interrupting your actual work happening on your computer. By virtue of what they've built, they don't stream the keynote on that. That goes to a commercial CDN because that commercial CDN is much more suited to deliver the keynote than the CDN they built for their one specific application. But again, we're talking about huge companies that can specialize. And even those companies that can specialize draw a line somewhere and say, okay, this is where our expertise stops, no longer a core competency. Who's the right partner for us to put the traffic on?
And a lot of it is related to latency because video is very prone to latency, especially live video. And I always compare it to sports because sports is like the second religion in a lot of countries, depending on what kind of sport. Like US and Canada, it's probably hockey, basketball, football, baseball. Where I'm at in Europe, it's all about football, soccer, as you tend to call it. And I've heard this really good anecdote from a streaming provider for sports who said that if you, I'm going to take a country for example, Italy. Italy is very much into football, but there's this divide in terms of capacity and infrastructure that is out there between the north that is supposed to be more wealthy than the south. But the expectations are the same. Like when Saturday or Sunday football comes, everyone wants to see it full HD, maybe even 60 frames a second. But there is not enough capacity down there. So what they tend to do is they have to build their own CDN because they don't have that freedom, that flexibility, all those options that the major POPs have.
Yeah.
And because it's very localized, they just build it out there because they don't have anything else. And I want to drive that back to one of the services that I know you provide as well is MicroPoPs.
Yeah.
I want to hear your take on that compared to building out a full-blown like edge pop.
Sure. Well, before we go there, since we promised we were going to geek out and have opinions, I will say you did just hit on one of my pet peeve.
Did I now?
Yes. So my one of my pet peeves is our inability as an industry, and it includes me because I do it all the time, to either A, choose our words better, or B, understand what we're doing. So I constantly hear latency thrown around, and depending on who you ask, you get different versions of what that means. So normally when you're talking to somebody in video, if they're talking latency, they hopefully mean glass-to-glass latency, meaning the time from when the camera captures the image to the time when it's displayed on somebody's screen. However, there's still a misconception that goes back truthfully to when it was all we could measure, where latency, that word in CDN, means time to first byte or actual round trip time. And
I'm guilty of that because I care about what's under the hood. I care about the delivery. I care about how we can improve this with caching. So definitely it is time to first byte, or even if you're talking about a little HLS segment, time to last byte as well. You want to have that chunk being thrown over the wire. You want it to be there.
So there you have it. So there's no HLS players today that do anything until they get the last byte of the frame that they're trying to render. So they can't pre-guess what the next data will be. So whatever data you need, whether it's the form of one long chunk or smaller chunks, or even frames within, let's say, a CMAF type streaming setup, at the end of the day, nothing actually gets played on the first byte. If you're measuring the first byte, you have 1 byte. 1 byte is not enough to render any video frame of any kind.
You have to go to your next keyframe and all the deltas in between before you have something playable.
And that it ties into that QoE conversation from before of, okay, well, now we actually have a way to measure it. So time to first byte goes back to, hey, it was really expensive and bandwidth was really hard, and we don't want to have to download a whole web page to see how fast the server is performing. But the reality is that's what the end user has to do. So latency, we also find in my experience that network operators are about 10 to 15 years ahead of web ops. So the way I think of it is latency or time to first byte is ping at layer 7. So it's an awesome measurement if all you're ever going to serve is a 304. fantastic. If all you're ever serving is a header, measuring headers is a great way to measure headers. If you're planning on serving 800 megabytes of HLS streams over the next 10 minutes, measuring one header is not statistically relevant in any conceivable way. And even if it was relevant in some conceivable way in 2008, the size and scale of the network has grown such that if you thought measuring 2 packets across an exchange point that, let's say, was 10 gigabits per second in 2008 was statistically significant, it can't be statistically significant to measure those same 2 frames when that same exchange point, rather than being 1 by 10 gig, is now 4 by 100 gig. Right? The volume of what you're measuring, if you're trying to find performance, has been scaling exponentially, but the amount of data that we use to measure how it's doing has stayed the same.
It stayed the same. Like, and it will continue to get worse. Like, I just bought a new TV, smart TV. It's a 4K device, but I could go for 8K as well, and we're seeing that increase as well. Like, yeah. I think GoPro released a new camera. It's a 5K camera, so they're already bridging that gap. 8K is just around the corner. When you go to these industry trade shows, they talk about 8K already. So it's just going to get worse and worse and worse. Until you reach that point where there's no significant improvement in upping those numbers, where you'll say, okay, the screen sizes are this big, internet speeds are this much. We're good with 8K or maybe 16K in the future. I don't know.
Yeah, and it's also that's part of the reason that time to first byte also becomes less and less relevant. It's not just the size and scale of the internet that you're trying to measure across, but to your point, in 1999, if you did a time to first byte measurement and you got 800 bytes back of, let's say, web header or HTTP headers, and you were trying to download, when the web page loaded, a 5K image, well, you're actually sampling like 10% of the experience. Doing that same 800 byte header download to measure the latency, and then proceeding to use that to download an 8K video, it's such an infinitesimal, you're talking about delivering 900,000, 1 million packets, and you're using 2 to try and predict how it's going to go. And not only that, you're using 2 small ones, which network buffers don't exactly work that way. But getting off that soapbox, which is my soapbox.
No, not necessarily. I want to add something, is that I get it. And like, even at our end, we have the measurements in place, like the timeouts in place. Like, typically in Varnish, when you connect to a backend, you can define timeouts. And there is a connect timeout, yes. And there's a time to first byte timeout, yes. But there's another one in between byte timeouts that is significant. And in Varnish Enterprise, there's also like a last byte timeout. So these measurements matter. And it's not like the industry isn't ready for it. It's just not in our collective consciousness, because we're so used to these typical, like, what do you use the internet for? To serve web pages. So the size will be manageable. So time to first byte is fine.
Yeah, and it's...
So yes, please stay on your soapbox until we drive this point entirely home.
Yeah, it's also relevant to that 2080 rule that you had, which is it only makes sense if you're looking at it from the 20. If you're looking at it from the 80 and the networking standpoint, you would go, what am I supposed to do with this? Like, this didn't tell me anything, which is what network engineers would tell you, right? Like, there's the insulting way of saying it is calling somebody a traceroute engineer, because ping and traceroute doesn't tell you anything about how it's actually going to perform, for a lot of reasons, not just that. It's more of a control plane, data plane thing. But that notwithstanding, the general approach, the best way I even if somebody's really sure that latency is really important, straightforward question. Would you rather be 20 milliseconds away, nice and low latency, with 0.5% packet loss? Or would you rather be 80 milliseconds away with 0% packet loss? Well, if you don't know the answer to the question, which you shouldn't, because the answer is still, it depends. What congestion control are you doing?
And
all that
and
sort
also
of
what
thing.
kind of traffic, like what kind of content are you putting over there? Because I wouldn't mind
not
buffering.
Not necessarily, because the challenge with the latency measurement is that because it's so small, you're not taking enough samples. you don't have a really good prediction of what the packet loss is going to be. And the way retransmits work in TCP, and even in QUIC, once we move to UDP, the congestion control, one drop packet is worth quite a lot of end user experience pain relative to even 10 milliseconds of latency on the network side. So latency is only as good as... So the best example I can give you is latency is super important for this call. Latency tends to be super important for anything real time because you can actually get away with a dropped packet, and you want to get away with a dropped packet. It's almost going back to the video streaming analogy where you're okay with dropped packets because you can give people a slightly worse video picture.
Or when it's video on demand, it doesn't really matter that it's a little bit slower in the beginning. You just buffer enough so you have enough. But for live video, that's impossible because your playlist doesn't have all the data yet. It comes as it comes, so there's no way to anticipate that. So that's why for live video is tricky, and in that respect, that latency is a really important factor. But for video on demand, I would go for less packet loss and slightly more latency, as long as the player can buffer enough to give us the experience that we want.
And you hit the nail on the head there, which is at the end of the day, you don't care about latency. You don't care about packet loss. You care about the experience that we want. And there's actual ways to measure and account for that now in RUM and QoE, where we don't need to guess as using latency as some sort of approximation. We don't need to use what we think the packet loss might be based on some predictive algorithm. We can actually measure people's experience and go, oh, that's what's happening. And the more we get away from trying to predict from test objects, because even a 50 kilobyte test object, it's better than just time to first byte. But as we talked about, it's in RAM, it's in the data center, it's no way predictive of what the end user experience is actually going to be.
Let me throw in another quote, one that we had in the prep call, because I don't want to claim it's my quote, but you say it's not about the hits, it's about how good your misses are, which is also a factor there, because not everything can be stored in cache. The amount of volume that is thrown over the internet is a lot bigger than what can be stored in a single node or a collection of clustered POP nodes. It's impossible.
Right. And
do elaborate on that, because I found that a really good quote.
It's actually not that different from what we're talking about now. So, to restate the quote, it was, it doesn't matter how good your misses are, it matters. It doesn't matter how good your hits are, it matters how bad your misses are. It doesn't matter how good your time to first byte is, it matters how you deliver the video segments. And they're not dissimilar because it's just a different view of the same thing, which is hits are easy, time to first byte is easy. Misses are hard, delivering the actual bits is hard. And what they have in common is that it's so much easier to measure the first one. It's so much cheaper, but it's not good data. It used to be good data. It was never that good data, but it's all we had. But in a world of measuring the videos, the player experience, in a world of RUM, we can always keep looking to how do we better predict what the misses are going to be, what that experience is going to be for the end user, what the actual throughput is going to be, not just the time to first byte. And all of that is more, we have the opportunity to measure, not infer. And the first two are both just inferences. And when all you can do is infer, do what you can. But when you can measure, there's no reason not to measure. And we're not quite there. So there's a delay in the measurements today, specifically about multi-CDN. Nobody has great APIs yet to fully feedback the performance data and say, actually, we watched somebody play an entire video off CDNX, and this is how many times it buffered, and this is how many times we had to lower the bit rate, and feed that back in so that the multi-CDN selection can say, okay, even though time to first byte is this, or even though the 50 kilobyte test object is this, we know that actually it wasn't very good. And if you know that it's actually not very good, and you have a way to measure that it's actually not very good, then you want to disregard the first two as often as you can.
So thank you, Matt. And thank you to everyone who took the time to be here with us. We'll do more webinars like this. But with that being said, thank you, everybody, and have a pleasant day. Matt, you have a nice day too.
Thanks, you too. Cheers.